So hello friends, welcome to my channel MN Coaching Center. So today I'm going to explain your 9th standard science chapter 12, that is sound. So let's come to the chapter sound. So every day you hear some sounds. There may be bird sounds, bell, machine, any sounds you may hear. So which form of sound do you hear producing that sound, how it produces, all the other things you will learn in this chapter. So here they have given an example. So they are taking a vibrating turning fork and they are beating it to the glass. So in the activity there is produced a sound by striking to the turning fork. So we can also produce that sound by plucking, scratching, rubbing, blowing, or anything doing to that object. So we set the object vibrating and produce sound. So vibration means a kind of rapid to and fro motion. So vibration means to and fro motion. So in motion or fro motion is called as vibration, and the vibration is called as vocal cords. So how the whistling sound accompanies a bee is produced. In a bee is produced the when you hear the bees makes buzzing sound. So a stretched rubber band when plucked vibrates and produces sound. If you have never done this, try once. So propagation of sound. So sound is produced by the vibrating of the object, whether that may be solid, liquid state, and the matter or substance that through which sound is transmitted is called as a medium. And when the object vibrates, it sets the particle of medium around it vibrate, and the particle does not travel all the way from the vibrating object of a ear to the ear, all the way from the vibrating of the object of the ear, and a particle of the medium is in contact with the vibrating object is first displaced from its equilibrium position. It is displaced. As a result, the adjacent particle gets displaced from its position of rest. The process continues in the medium till the sound reaches to our ear. This happens continuously. So as you know, air is most common medium through which sound travels. When the vibrating object moves forward, so it pushes and compresses the air in front and this region is called as compression C. It is called as C. And the move when the vibrating object move backward, it creates a region of low pressure, and this low pressure is called as rarefaction. This is called as rarefaction. And the propagation of sound can be visualized as propagation of density of variation or pressure variation in the medium, it is also said. So here a vibrating object creates a series of sound like this only. It creates a series of sound where it is a series of comprehension. Sound is a series that is called as comprehension, and rarefaction in the medium it creates. So sound needs a medium to travel. As you know, sound needs a medium to travel. It travels in air, water, steel, etc. So it propagation, it cannot travel through a vacuum because which can be demonstrated by the following experiment. It cannot travel in vacuum. We can demonstrate. So here they have taken in this experiment a electronic bell, a bell jar, a cork, a switch, and two electric connection. So the same current is passing through the bell jar. Here the current is passing through the bell jar, electronic bulb, and after sometimes when less air is left inside the bell jar, you will hear a so when we on the bell jar, when there is no air, there is vacuum, we can't hear any sound. But when you on the bell jar, so you can hear a little sound. When you leave little bit air into that, you hear little bit sound. So here longitudinal way in a slinky, or they are taking a spring. So here they have taken a compression, and the region in which the coils are further apart are called as rarefaction. So compared to the propagation of disturbance in a slinky with the sound propagation in the medium, these waves are called as longitudinal wave. wave it is called as. And next, let's know about the characteristics of sound wave. What all the characteristics the sound wave forms? That is frequency, amplitude, and speed. Frequency, amplitude, and speed. So the density as well as the pressure of the medium at the given time varies with distance, and above and below average value of distance and pressure, the density and pressure moves. They are saying, and also compression or the region where particles are crowded together and represented by the upper position of the curve, and the peak represent the region of maximum compression it shows us. And distance between the consecutive compressors is called as C, or two consecutive refraction it is called as R, and this is called as the wavelength. The distance between the compression and the refraction is called as wavelength, and the wavelength is usually represented by Greek letter lambda. It is represented, and the SI unit is meters, as you know. Lambda it is represented. So frequency tells us how frequently an event occurs. How it occurs, frequency tells us about that. Suppose there may be beating of drum, how frequently it is beating, the frequency tells us about that. And the change in the density from the maximum value to the minimum value, again the maximum to the minimum value makes one complete oscillation. So the changes from maximum to minimum value in the object is called as the oscillation. It can be said as oscillation. And if we count that refraction that crossed upper unit time with the frequency of the ground sound wave, it is usually the frequency is represented by V in the Greek letter no, and the SI unit of it is hertz. HZ means hertz. It's hertz. And the time taken for the consecutive compression or refraction to cross the fixed point is called as the time period of the wave. It is called the time taken is called as time period. So it is represented by T, and the SI unit of time is second now. So the frequency is 1 by T, time period 1 by T we can take, where a violin and a flute may both be played at the same time. They both may be played at the same time in a orchestra. Both sound travel through a medium. The both sound travel through a medium, but the both sound travel at the same speed irrespectively. The both sound travel same speed. So pitch is one of the characteristics of the sound. The pitch, how much pitch the sound is there, they will see. So the high pitch sound corresponds to more number of compression or refraction. If there is high pitch, it has more compression and refraction. So object size and condition depends on the vibration at different frequency, the vibration how it happens, and the magnitude of the maximum disturbance in the medium on either side of the mean value is called as amplitude of the wave. It is called as amplitude of the wave. And amplitude here it is determined, and the loudness or softness of a sound is determined by basically by its amplitude, the force amplitude. The amplitude of the sound wave depends upon the force with which an object is made to vibrate, or by which it strikes a table lightly. So we have heard some of the soft sound, some of the hard sound. So loud sound can travel larger distance when associated with higher energy. It can travel a higher distance, we can see. So as it moves away from the source, its amplitude as well as its loudness decreases. So it can be show waves. This is here in this photo you can see, this is the first one is the soft sound, and here is the louder sound. See how much high waves are there. Here see little bit wave, soft sound it is. So okay friends, till here I have explained the sounds chapters. the frequency, amplitude, corresponding rate fraction. So I will explain the next topics in my next video. So till then, take care, bye, see you, have a nice day. So like my video, comment on my video, and subscribe my channel and coaching center for more video. I will explain the next topic in my next video. Till then, take care, have a nice day, bye friends.